This is the first lecture for Chapter 8 for Stats 253, and the topic is hypothesis testing. You've seen situations in which one result was previously held, and then a new result comes in and has a new measurement. And then the question is this new measurement significantly different from the previous one, or is it so close to it that we can just consider it the difference just due to noise or a little bit of change in experiment? And that's what hypothesis testing is about. It's a procedure to determine if a new result is significantly different from the previously held one. I had some examples in the lectures. Let's say a drug was assumed to have no effect on bradycardia. In that case, the previous idea or the previous result was zero, no effect. Then there's a new study, and 15% of the people show bradycardia, which is a slowing of the heart rate, a slower heart rate. So now, is this new result just insignificant? So we can still assume that the effect on heart rate is zero. Or should we reject that idea and say, no, the drug may have an effect on heart rate? To use hypothesis testing, those ideas that I was talking about with the drug have to be reformulated into hypotheses. And there's going to be two of them. One is called the null hypothesis. Some people make a joke and say it's the dull hypothesis, but the null hypothesis. This is a statement about the current situation or the ideas that you had previous to the study. It's called the a priori idea. That's what this is. The previous ideas or measurements. Right. Then you have an alternative hypothesis, and that's also labeled with an H, but this time a little 1, subscript 1. Null hypothesis has a 0 beside it. Remember, the alternative hypothesis says that there is some difference, some significant difference between the previous idea and the newly measured test value. Now, these differences can take one of three forms. It can just be not equal to the previous result, or it could be less than or greater than. So after we formulate these hypotheses, which as you can see is non-trivial, then we use the methods of hypothesis testing, perhaps the p-values, and we do that in order to reject the null hypothesis and accept the alternative, or not reject the null hypothesis. Again, it's not a method to determine what the new value should be. It's just to determine a comparison between the old and the new in a very general way. For most cases that we're going to be doing in this class, the null hypothesis is with respect to the mean of some previous measurements. So you had a previous measurement, and we'll call that previous mean mu naught. There'll also be a standard deviation associated with that measurement, which we'll make use of later. Okay, so you're going to have from here a null hypothesis and the alternative hypothesis. The 1 can be because that's at times 0, right? And the null hypothesis will say the mean is equal to the previous mean. And here's your alternative. It could say, I'm going to put it like this, it's going to say one of these three, not all of them. It could say the mean is really less than the previous idea. The mean is just simply not equal to the previous idea. It could be greater or less than the previous mean, or you're left with only one case here, greater than. Okay, so this is your null hypothesis, and this is your alternative. As far as mu goes, it's usually some parameter of interest. I've just written it here in general, but you usually have something that you're measuring. So for example, say you say the troopers did some study a while ago and decided that the average speed along a certain stretch of highway that the average that the cars were going was 65 miles an hour. Okay, so this was the old one. This is your speed, and this was the average of it. So this is your mu naught. This is your previously held a priori idea. Okay, then a new study comes along and looks again at the speed of these cars and says, no, people are going more like 75 miles an hour. Okay, so here is the formulation into null hypotheses, which will be that the speed equals 65, or the average speed. You could use mu, but we'll use S for speed, and that'll be fine too. We have the alternative hypothesis. In this case, would say that the speed is really greater than 65. Notice it doesn't say 75. We're going to use that later. It just says, in this case, greater than. You also could have said not equal to and implied that it could be slower, but since your data is showing faster, the sort of the obvious choice would be that the speed is now greater than 65. And I just used an example here with S being speed. It could have, you could do something else, and for example, the parameter of interest might be the temperature. All right, say the average temperature is, I don't know, 10 degrees somewhere, and that was what you measured years ago. And that's your average temperature. This is your mu naught. Okay, so your alternative or your null hypothesis will say that the temperature, or the average temperature, is 10. Okay, the new measurements come along and say, no, the temperature is really like 7, right? So the alternative hypothesis in this case might be that the temperature, in this T, meaning the average temperature, is less than 10. So when you do the procedures that we're going to describe in the future videos here, you can still make an error. In fact, you're never going to say you've arrived at the truth. You'll say with a certain confidence, right? But if you make an error, there are two errors, and they're called type 1 errors and type 2 error. Okay, in type 1 error, you rejected a null hypothesis when it should not have been rejected. The type 2 error is a failure to reject a null hypothesis when you should reject it. Now there's some wording here. Sometimes people say in casual speech you accept the null hypothesis, and that's not really correct. You're not testing the new hypothesis. You already accepted that it was true. Also, you're not proving it at all. You're not proving that the average speed along that highway was 65 or 75. You're not proving that. You're just either you're going to reject that null hypothesis or you're not going to reject it. Seems like a minor point, but and later on we'll have a lecture on the some of the problems associated with hypothesis testing. But remember, we're not proving anything, and you're certainly not proving the null hypothesis because you've already accepted that it was true. So to show these type 1 and type 2 errors, it's common to use a table similar to the contingency tables that we used earlier. Okay, here we're going to use the legal system, and the idea is that person is either innocent. Well, first of all, you're assumed to be innocent. So your null hypothesis is that the person is innocent, because that's how we start off legally. All right, so in this case, I'm going to write here that the null hypothesis is true. Remember these words, this H naught, which I just wrote here in this column. No reason to really write it in the column, but I did. This is your null hypothesis. Okay. And now over here we can write that the null hypothesis is false and the defendant is really guilty. All right, now I can't prove innocence. I'm assuming innocence, but these are kind of minor points. But what I really want to show you is where these errors come in. Okay. Now, if the jury convicts the defendant and the defendant was guilty, that's a correct decision. If the jury acquits the defendant and says not guilty, or rather not enough evidence to prove guilt, and and the defendant was actually innocent, that is, null hypothesis was true, that's a correct decision. Okay, now in the homework you have to work out one of these tables like this, and the correct decisions aren't always, they're going to be in opposite corners, but they might be in this corner and this corner instead of in the other two corners. So just work it out. So if you convict somebody and they're guilty, that was correct. If you let them go and they were innocent, that's also correct. Now, the type 1 error is when you convict a person, or rather, you're rejecting a null hypothesis that really was true. So the null hypothesis is that the person is innocent, and you throw him in jail. That's a type 1 error. Okay. Now if you acquit the person, okay, that means you accept the null hypothesis, but it was wrong because the person really was guilty. That's a type 2 error. I think, although we aren't going to do any problems with this example, it's sort of an easy way to remember where the type 1 and type 2 errors go. Now this is statistics, of course, and so we aren't going to say we have rejected the null hypothesis and that's it. We usually say with a certain confidence. So we're looking at confidence levels similar to what we did for the confidence intervals. In fact, you'll see very similar techniques over here on this hypothesis testing. So alpha is going to be the probability, or is used as a probability of making a type 1 error. Right. So when the null hypothesis is rejected, it should have an ED on it, then it is stated the null hypothesis is rejected at a 1 minus alpha confidence level. So if you want a 95 confidence level of confidence that you as you reject your null hypothesis, then you want alpha to be 0.05. Right. Beta is the probability of making a type 2 error, and 1 minus beta is called the power of the test, and it's not really measured. All our calculations are going to depend on the alpha that we choose. So now this is exactly the same table that we had before, but now I've put alpha and beta in it so you can see where they go. So let's look at correct decisions. The null hypothesis is rejected here, and the null hypothesis was actually false. That is a correct decision. Now if you don't reject the null hypothesis and it was actually true, and again you have another correct decision. Okay, the probability of making this correct decision is 1 minus alpha. Type 1 error, you rejected a valid null hypothesis. The probability of this type 1 error is alpha. In the lecture notes I have some examples in these boxes, but it's too complicated to show here on a slide. For the type 2 error, here's your type 2 error, the probability of making the type 2 error is beta. For the correct decision, probability of making this correct decision is 1 minus beta, again called the power of the test. We aren't going to do anything with that. We're only going to work with the alphas.